Hello everyone, welcome to Clashing Coder. So in this video we will see the question that is partition labels. So it is a medium level question and the problem statement is a string s of lowercase English letters is given. So we want to partition this string into as many parts as possible so that each letter appears in at most one part. That means that we are given this string of length, length like it will be in between 1 to 500, and we are only given the lowercase English letters, that is from A to Z, and we have to partition the string in such a way that a particular character occurs in only that partition. It does not occur out of that partition. So for example, in this string you can see each letter appears in at most one partition, and we have to return the list of integers representing the size of these parts. So of this string we have made 3 parts. You can see maximum parts that we can make are 3, because you can see A occurs in this part only. After that you can see these are the other parts, and A does not occur in these, and B also occurs only in this part, not in that other parts. So we have to make the maximum parts that we can make of a particular string, and all each character should occur only in one part at most. Should not occur. It should not be like if A is here and A is also here, then we will have to increase our size of this window or this partition and merge these partitions also if A occurs here. So here it is that this partition is so that each letter appears in at most one part, and a partition you can see here we are given another example also. Here they have merged these partitions. So actually this is also logically correct, but we have to find the maximum possible partitions that we can make. So this is a wrong answer for this particular question, because we have to find the maximum partitions. You can see at D we can make the another partition starting from D, because A does not occur after D, and from all the characters in between this A to A does not occur after this A. So that's why we have to make maximum partitions possible. So let's see how we can solve this. So actually if this is the same example that we are given in the LeetCode. So let's see. So this is our string. So if you see the first occurrence of A is here, so we have to find actually the maximum occurrence. So maximum occurrence of A is at this point. So you can see A occurs at this point. So if you check B occurs in between this range. It is inclusive in between this range, and here also B occurs in between this range, and C also occurs between this window or this range. Actually you can see. So this is luckily we have got the first character only got our first partition. So now if you see for D, we have to actually make the partitions or the windows. If you see D, so now D occurs at this point, and the ending or the last time the D occurs is at this point. But if you see E is not in between this range. It is actually occurring after D. So we will have to extend our window for that particular character, the maximum that we can extend. So it will be at this point. So now if you see F lies between this range, and E also lies between this, and G also lies between this range. So now we can like this how we will make the partitions. For this you can see H lies here, and second or the last occurrence of H is here, but this is not the full window. If you see I lies here, so we will update or extend our window till here. Then we encounter J. So J occurs at this point. So we will again extend our window, and we will getting this point, this whole 3 partitions. So now what we have to return is we will simply we will use the indices to find the length of the particular string, because we don't have to print it. So we will simply use the indices. So if for example if it is E, so it is S, so we can simply do E minus S plus 1 for making it 1 based indexing instead of 0. So we can simply do plus 1. So let's see how this algorithm works. I hope this you got it clear how we can think of this approach as a Windows approach, or you can say, and then we have to extend the windows. So let's see. So actually for this approach, what's happening? So actually for this approach we will create a count array, you can say, from A to Z, which will contain the last occurrence of this the index of last occurrence of the particular character. So you can see in this given string A occurs last at 8th index. You can see A occurs at last at this index. You can see 8. So this is how we will make this array. And for the for example E occurs last at this index, not this, actually it is wrong, sorry, I will change it. So you can see E occurs at this point, so maximum will be 15. So let's check it again. A is last at 8th, and B occurs last at 5th index. So actually this is at 5th index, so you can see 5th index. And then if you see C occurs last at 7, D occurs last at 14, and E occurs last at 15, F occurs last at this 11, and G occurs last at 13, this H occurs last at 16. Okay, no, 19. So actually I've made a lot of mistakes. So it is 19. So now you will be also able to understand how we have made this array. So it will be actually from A to Z, but I've only written this for from A to L because our string only contains from A to L. So I have, like, due to the space, I've made it like that. So for I occurs last at 22 and J occurs last at 23 and K at 20 and L at 21. So I will show you in the code how we can make this array actually, but now let's see the intuition or the algorithm, how we will use it. So if you see, we will have to, after making this, we will get this array, we will have to initialize two variables, that is start and end. Actually at start, at the starting, start and end will be at same position, that is 0, and I will be our pointer, or you can say traversal, or for use that we will use for our traversal. So if you see I, so now our start and end are 0, and will be our the ending point of the index, and we will extend it whenever we want to, because for this example, as we saw, D occurs at this point, so start will be over here and our end will be at this point because of the last occurrence of D is at 14. But if we encounter E, so end will be extended to the last index of E, that is 15. It is greater than the D. So let's see so how we can do that. So I will not show you fully, but like I will show you the intuition actually. So if you see here, I is at this point and our end will be the maximum of this you can see of the, like, start is at 0 and end will be maximum of the particular occurrence of this like index of this A. So the last index at A occurs is at A, so end will be set to this point, that is this A. So now our end is at here and start is at here, and I will move to another next point, so it will become coming here, that is 1. Then I will see that we will check end will be like updated. I will write it here also. So actually end will be max of the previous end and the current value that we are getting from this value, that is count, and the character that we are checking. So this will be the character. So now we are at B character, and the value that value of the B is this from this array is 5. So if you see, 5 is smaller than this 8. So it will stay to its previous value, that is A, and then we will again come to A, and A is previous value is 8, so it will be not like extended. Then we come to B and nothing happens. Then C, since C's value is 7, which is smaller than the previous value of E, that is 8. So we will simply not extend this window, and similarly we will keep like I will reach to this point, that is 8. When we will see, when I and E becomes equal, that means we have traversed the full like window, and we have not found any character which occurs after this this window. So we have made our one partition actually, if you see. So now what we have to do is to find the length of this is we can simply write you can see I or E, you can write they are at same index, and then we can simply do I minus S, and for making it 1 based indexing we can simply do +1. So if you see, the value of I here is 8, so 8 minus you can see this is S, so S is actually 0, so 0 plus 1 to make it a 1 based indexing. So we got the value 9. You can see our first length of the first string was the partition was 9, so we have got the correct answer. So now what we have to do is we will set this start actually to the I plus 1 index, because now our one partition has ended, so we need to update our start. So it will become I plus 1, which is 9, so start will come here. Now let me erase these values actually. So now our I will be starting from this point. So what we will do now, we will check the ending point of D. The ending point of D is 14. So we will set our E to the ending point of D where it occurs. So now when I comes at this point, that is E, so we will check the ending last instance of E, which is at 15, and 15 is greater than the previous value of E, which is 14. So now we will extend this window and E will come here instead of this. So E will come here, that is at E. Sorry for the handwriting, I am using the mouse, so it is not easy to write. So now if you see, now we will traverse to this, I will come here F, and F is the last instance of F is 11, so it is not greater than E, that is 15. So then E is actually 15 only. Then G 13 is not greater than E. Then this D actually it is also in between this range. So now again I will come till this point and E will stay as it is, because we have no other character which occurs after this partition, this actually this window. So now if you see I and E are equal, so what we have to do is simply find the length. So now our I will be, you can see I is our 15, so 15, let me write it, 15 minus the start is 9 plus 1, so what will get, it is not showing the answer, what's happening. So yeah, so let me show you. So 9 minus 15 will be 6, so plus 1 will be 7. So now we have got the second partition size, which is 7, that is 2. So now similarly for this also we will again run our loop. Loop will keep running and we will find the maximum point at which occurs this letter occurs. So let me show you that also quickly. So let's see. So these were our partitions that we formed actually. And these were our partitions. So now our I will be here and starting will be also here and ending will be set to the value of this h, that is from this point, this array, that is 19. So end will be coming here. So now I comes here, that is at L. So that is I, actually this is I, not L. So if you see, let me check it, or so yeah, this is I actually, not L, this is I. So if you see, this is I. So if we check the last point, so it is 22. So 22 is greater than the previous value of E, 19. So we'll extend it to this point. So now it has extended all the way to this point. Now if you check, I will come to J. Now if we check the value of J from this array, it is 23, which is greater than the previous value of E. So that means we have to extend our window. So now our window will be extended. So similarly, it will traverse to the remaining elements, and then we will be left with this partition. So now we will simply find this value, that is E is 23. So 23, that is I minus 23 plus minus his starting value and plus 1, so which will be 8. So this is how we can simply find our like partitions and the size of the partition and print it. So let's see the code also. I hope you understood this solution. Actually here we are using only one traversal, so it is time complexity will O of n and the space will be also O of n. So let's see the solution. So I will code it. So first of all, what we have to do is we have to prepare a count array. So what we vector you can say. So actually we will do int and count, or actually I will name it as last index. So last index, and it is of size 26, and we will initialize it with -1. Then we will like start traversing through this string, that is for I is equal to 0, I less than this s dot size and I plus plus. Then we'll simply get the value of the last index actually. So s and I, and we have to actually subtract the value of my ASCII value of -a. So let me tell you that at this point, if you see the ASCII value of for example ASCII value of C is 99. So how we can map it to this array at the index 3? So that for that we have to minus or subtract the value of A, the ASCII value of A, which is 97. So it will become 3. So it will become 2, you can see. So now 1 0 1 2. So it will be mapped to this 2 index. So we have to, that's why we have to subtract the minus the ASCII value of A. So now we can simply do plus plus actually I, that is the index at which it has occurred. So now what we have to do is, now we will get our last index array. Now we have to make our result vector. So that's what we have made. Now we'll simply again traverse this string and I less than s dot size and actually I plus plus, and now we have to also initialize our variables, that is start and end. Start will be 0 and end will be also 0. So now for every like this point, we will check and will be our maximum of the previous value, that is previous end, which is 0 now, and the current the value that we are getting, that is last index of s of I minus a, to map this minus a, and then and will be updated to the maximum value. As I told you, it will be updated to the maximum occurrence of this value, that is 15. So if end is at this point 12, so it will be like this point actually 14, so it will be updated to this value, that is 15. So it will come with that. So now what we have to do is, if we will check for the condition when the partition ends, it will be when I is equal to end, then we will simply add the result actually emplace back. So why I use emplace back is because it is faster than the pushback function actually. So now we have to make I minus s plus 1. We can simply insert that. So as I told you, I hope you remember that that we did here the calculation. So now what we have to do is also update the start to I plus 1, because we have to make the start also to the starting the point to the starting of the next partition. So that's what we are doing. So now we have to simply return the result. I hope this works actually. Let's see. I hope I haven't made any mistakes. So as was I. So actually, yeah, it should be comma here. So you can see it has, let's submit it. So yeah, it got accepted. You can see it ran in like 4 milliseconds, and it was faster than 97.66% of solution, and it took less memory than 87.80% of solution. So I hope you like this video, and I will share this code in the description so you can refer it from there. I hope you understood how we can solve this question and all the intuition behind it. So guys, do like this video and subscribe this channel and share this video. Thank you for watching, guys.